Hi there everybody, it's Mr. Neil here. We're going to go through position time graph conversions to velocity time graph conversions. So let's start with our basic position versus time graph, like so. Now recall from previous classes that when we find the slope of this, the change in position over the change in time, we wind up with a vector called velocity. And just a little note here, I'm going to draw velocity as v with an arrow over it to show that it is a vector. Just a little way of reminding you of that. Alright, well if I want to graph velocity versus time instead of my position versus time, it's actually really quite simple to convert. Let's say my velocity is 5 meters per second, and that means it's true for any point in time on this graph because it's a constant slope. Well, I come over here to velocity time and I'm going to graph that 5 meters per second. Because I'm just graphing a number, I wind up with a flat horizontal line at plus 5. Well, let's flip this graph and let's look instead of the positive slope at a negative slope. How is this going to change our velocity time graph? So again, our slope is our velocity and we need to graph the slope onto our velocity time graph. Well, the first thing you'll notice is I've added a quadrant to the graph so you can see where this is going. Let's say this is also 5 meters per second. They're both traveling at the same speed, but they're traveling in opposite directions according to the graph, so I've thrown a negative sign in front of it, and that corresponds to our slope on the green graph here. Well, if I'm graphing the slope, I need to graph a negative 5. I'm just graphing a number, so I have a flat horizontal line at negative 5 meters per second. Easy as that. Okay, one other shape over here on this screen we're going to look at. Whoops, let me try and get a different color. One that stands out from the first two graphs. There we go. So this darker blue is going to represent a position versus time graph with no slope, aka at rest. And if we have no slope, we know it's equal to 0 meters per second. So if I were to sketch a velocity time graph for this one, I'm going to draw it below here so we can keep it all on the same screen. Then I'm just graphing the number 0. So I just sort of scribble over the axis to show that I'm at 0. So these first three graphs represent what we call uniform velocities. In other words, they do not change. So our velocity is either equal to 0 at rest, our velocity is greater than 0, it's positive, it's moving away from the origin, or our velocity is less than 0, it's negative, moving towards the origin. In none of these cases does our velocity increase or decrease. However, there are times when it will do so. So the next video is going to look at the couple of shapes of graphs that correspond to a change in velocity.